Hello, everybody, and welcome back. We're still looking at the 2019 Manitoba Math Contest. We're up to question number 5 out of 10. So we've got two parts here for question 5. A part, which number is greater? Square root of 6 plus square root of 10, or square root of 5 plus square root of 12? Well, this would be fantastic. Fantastically simple. We just grab our calculator, except we're not allowed them. Shame. What could we possibly do to figure out? Well, I noticed that both expressions, the capital A and capital B, are sums of square roots. Now, I'm really bad at figuring out square roots. I suppose I could probably try. I mean, you can do square roots by writing them out. There's a written way to do square roots, but I'd rather avoid that. If you haven't seen it before, it's sort of like a long division that you have to think your way through a little bit more. But I suppose you could probably try and do it that way. I don't know how close these two actually are, and I'm not going to check on my calculator. But I don't like working with square roots because it's hard to compare. But you know what? They're both positive integers. So if a is bigger than b, a squared would be bigger than b squared, and maybe I could get rid of those square roots, at least a little bit. So that's the first thing that pops into my mind. I get question 4 out of the way. So I'd say a and b are both greater than 0. Clearly, I don't think that really needs justification. So a squared greater than b squared happens exactly when a greater than b. And similarly, b squared greater than a squared happens exactly if b is greater than a. So I'd say something like, let's instead consider, or actually let's not say consider, let's say compare. Compare a squared and b squared. So a squared, that's going to be root 6 plus root 10 squared. Now we know how to do squares, so root 6 squared is just 6, root 10 squared is just 10, and then you'll get 2 copies of root 6 root 10. But of course, if you have square roots multiplied together, you can just multiply the numbers under the square roots. So 6 and 10 is 16, and then we'll get 2 root 60. Now you say, well, you've got more square roots there. This isn't going to be helpful. But the next one we're working with is root 5 and root 12. And if you just think ahead to this step, 5 and 12 are going to combine to give me root 60 as well. So this is going to work out in the end. So 5 plus 2, root 5, root 12, plus 12. 5 and 12 becomes 17, and then we get 2 root 60 as well. So we see b squared is actually exactly 1 more than a squared. And so I conclude that b is the bigger of the two numbers. Okay? Now, just sort of thinking ahead to other math contests, what might we do if we were sort of stuck with that 2 root 60, and maybe if we did b squared, maybe it's something like b is root 5 plus root 11, something like that, or trying to think of numbers that would cause a bit more of a problem. But maybe we don't get the same square root. What would I try and do then? Well, I would still be on a quest to get rid of the square roots. So I would bring the 16, I'd do a squared minus 16, and then I'd square that again, and compare that with the b squared minus 17, square that again, and try and do something like that. And that's typically how, if I've got lots of square roots in a thing, in an expression, I slowly get rid of them by squaring, rearranging, put all the integer things, all the things I know are integers on one side, and squaring again. You can sort of whittle away square roots. So the little tip for the future here. But we've got a b part, so let's take a look at the b part. Imogen draws an irregular 5-pointed star inside a circle. Okay. She measures the angles of the 5 points and finds, so 5 points, I assume this one, this one, this one, this one, and this one are what we're talking about. She finds that no two are equal. The largest one measures 60 degrees. Show that the second largest is more than 30. So willing to bet, based on sort of geometric shapes, that there's for sort of a 5-pointed star, there is a constant sum for these angles. I don't know what it is, but I'll work on that in a moment. And so whatever that is, call that sort of n. If you remove the 60 that I know, you'll get some other number. And to show that the next largest, so if I call A, B, and C the other ones, then n minus 60 would be A plus B plus C plus D, which would necessarily be less than 4A. And so I want to show that this expression here, so I want to show that A is more than 30. I want to show that this expression would be 120, I guess. So I'm predicting that the sum of these is going to be 180, just based off what I think you would have to do to answer the question. But let's actually dive in and try and find out, shall we? Okay. I don't think the circle thing really matters. It should be just a 5-pointed star should have this property. Okay, so how do you make a 5-pointed star? I start here. And so you go around by, so if I call the inside angles A, B, C, D, and E, so I go this direction to go back in this direction. Now we're doing 360 minus A. Down here, and to switch directions, we go around, right? I'm always going, actually, suppose we could always just do this clockwise. So to go from this angle to this one down here, you go by A, and then by B, or sorry, I guess this is D, then you go counterclockwise by B, and then you go, or sorry, clockwise by B, and clockwise by E to get to C, and then clockwise by C, and then you're back on track for A. But, how far have I actually turned in total? So I'm on the sort of, I start on sort of the underside of the shape. Oh yeah, I think it should be 180 degrees. Is there a better way to do this? Yeah, probably. Let's just see if we can think of another way. Because I don't know whether or not you have to justify that the sum of the interior angles is 180. I'm sure in their solution they probably just state it casually, but whether or not they were actually looking for it is another matter. Now, I know these angles here, because it's a pentagon, have to add up to 450 degrees. So if I call that Z, Y, X, W, U, this is 180 minus U, 180 minus W. And so this should be U plus W minus 180. And similarly, we can get each of these. And so you're looking, so the sum of angles at the points should be, let's see, this one here would be U plus Z minus 180. And then we get Z plus Y minus 180 at the top, Y plus X minus 180 over here, X plus W minus 180, and W plus U minus 180. So that's the sum of all of them. But we get 5 copies of 180, and we get 2 copies of U plus V plus W plus X. One of these should probably be a V. I don't know my alphabet. I just pretend I do. V, W, X, Y, Z. And we know that that's 550 because it's a pentagon inside. Okay, so that would be 900, and this would be 1080, so difference of 180. So I think you could probably do that sort of argument, or you can do my argument where sort of imagine you're standing on this side of the line, and then you rotate here. Now you're on the inside track here, but you've rotated by 180. You rotate again, and again. You're always staying sort of on the inside track, and then you wind up on the inside track again. How far have you actually sort of rotated yourself? Let's see if I can think of another argument. There's probably an argument about sort of sliding the shapes. So if I were to take this angle here and extend it up here, also pointing up off in that direction. And then there's that angle there, and you might want to bring it around. Yeah, I think there's probably a couple ways you can do it. But so I'm saying there's a good justification for the sum of these angles in here being 180. All right, now let's move on. So some of the angles in the inside of my triangle are 180. In case they wanted me to prove it. So I'm going to say one of them 60, and then we've got A, B, C, and D. You see that 180 should be 60 plus A plus B plus C plus D. We can also note, because they're all different, we're told 60 is the greatest, we know 60 is greater than A, greater than B, greater than C, greater than D. So now I can rearrange, say 120 is equal to A plus B plus C plus D, which must necessarily be less than 4A. So 120 is less than 4A. Divide both sides by 4. You get 30. The second biggest angle, 30 is less than the second biggest angle, or the second biggest angle is greater than 30, which is what they wanted to prove. So there's sort of two parts going on here. You might want to briefly explain why the sum of the angles inside the points is 180, and this will be true actually for any sort of star figure. Some of the angles inside one that does 6 should be 180 as well. So you get that, and then you say, okay, 180 is 60 plus the next 4 in a row, and rearrange to get yourself a nice little inequality. That's it. So that's question number 5. Up next, question number 6. If you're interested in watching that, feel free to join me. If you haven't given question 6 a try, might I recommend it? I'll see you next time.